I'm Stephen Claude Jalocy. I'm the Director of Streaming and Broadcast Distribution for ESL FACEIT Group, which is the world's largest esports company. So I'm here to talk a little bit about broadcast and a lot about streaming and some about esports, but that's probably the best place to start because it's 2023 and most people here probably know something about esports, but just in case, it's always safer to do a little bit of what is esports. So, what is esports? Esports is competitive gaming, which basically is people playing computer games competitively as a sport. And that's at all different levels, like amateur, grassroots, or recreational level, national, international, professional level. The most important thing to understand is esports is like saying sports. There's all different kinds of sports. There's motorsport and racket sports, ball sports. Esports is the same. There's first-person shooters, there's strategy games, racing games, all different kinds. So you have soccer, tennis, hockey. We have Counter-Strike, Dota, StarCraft. At the professional level, esports is professional players, international teams, world championships. It's millions of viewers. There's millions of dollars in prize money. It's sold-out stadiums and festivals. It looks a little bit like this, which I quite like using this photo because it really gives a sense of how big esports is now. There's a lot of well-established companies in esports, so there's ESL, FACEIT, DreamHack Sports Games, Vindex, Esports Engine. All of those together are the ESL FACEIT group, and we cover basically every aspect of the esports gaming business, every conceivable B2B offering, a whole suite of direct-to-consumer products, everything you can imagine. And most importantly for today, we are the definitive tournament and event organizer. We're a rights holder and we're a broadcaster. And every year we do hundreds of events all over the world. I picked some rough numbers that I could find. There's a lot of live days, there's a lot of live hours. I think whatever that says there, 18,000 plus live broadcast hours. That's just incoming program feeds. That's not all the elemental stuff, any remote production, any egress, anything like that. So it's quite big. And for most of those events, EFG is the owner, executor, end-to-end. So we handle every aspect of that event, from the stage and the tournament, the arena experience, the production, the IT and network, and the streaming and broadcast. So let's talk a little bit about traditional sports and esports workflows. Basically, right now, traditional sports and esports look pretty similar. I think that's a photo I took in an NHL game a couple of weeks ago, and then that's a photograph of a recent-ish esports event, an ESL event. And when we look at the broadcast workflow, it's pretty simplified, but a lot of TV, traditional sports broadcast workflows look like this. You have the arena, stadium, lights, cameras, the pitch, that's what you're watching. And then you have a production. If it's a remote production, you might have a little bit of difference there, but it's basically the same, so we'll stick with a simple one. This one. So you have your sport happening in the arena, and you have your production, and then you have transmission by satellite, or more common now, it's IP over some kind of managed network. When you look at the esports workflow, it's very, very similar. There's almost no difference at all. The only main difference, transmission, we're going to talk about that a lot, and the other difference is in-game production. So in-game production is pretty important to understand when we talk about esports, and especially when we get into talking about streaming, encoding, and all that stuff, because in-game is really what makes esports different to traditional sports. So let's talk about that. Esports in-game. Basically, it's the virtual playing field. That's the easiest way to try and explain it. When you're watching traditional sports, you're watching cameras that are following a match. It's happening in a pitch or a rink. The players are running around, and you're watching that. In esports, in-game is the virtual version of that. All the players are competing against each other on a game server. It's happening in real time. It's being rendered in real time, and it's being observed. Observing is what we call it when you follow the action of the game with virtual cameras or POVs or however it's being done. Observers are the people who do that. They're technical experts in the game and also in esports in general, and they understand everything that there is to understand, but it's also highly creative. They're essentially telling the story of the match. They're essentially the TD in traditional sports. And there's all these different kinds of elements included, cinematic overview action cameras, there's third-person cameras, POV, there's all the graphics, the HUD, and then also there's cameras from the production line, so replays, slow motion replays, picture-in-picture, blah, 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 blah. All that stuff you would see in sport, it's the same in esports. So, why is in-game important? It's important when you start to talk about this stuff, because in-game has much higher demands than traditional sport in terms of just encoding cameras. Encoding cameras is pretty easy. Essentially, there's a wide range of quality that is acceptable for cameras in terms of making the final quality stream of a football match is really, really, really easy when compared with encoding esports. And the reason for that are some of these bullet points, which I'll just generally fly through, but essentially there's really high expectations from the audience. Everyone who's watching esports, they play games at home, they want some kind of approximation of what they're actually playing at home. And obviously we're never going to get quite there, but that's their expectation, is it should look very similar. There's a really high demand on frame rate, has to be high, has to be smooth, detail is really important. 1080p 60 is the bar right now, a really good 1080p 60, but 1080p 60 is also the absolute minimum. 720p 30, you'll still see that in traditional sports as the final output. That just isn't acceptable in esports. And the final thing that makes it difficult, is every game is completely different visually. So you have all these different elements, whether it's the camera angles or the perspective or high motion or effects or anything like that. Every single game is completely different. So with cameras, like you sometimes have, you have a tennis ball or you have a puck or something that's difficult, but in general, you can kind of do a one-size-fits-all, you can capture everything. In esports, you pretty much have to tune your encoding to fit the game you're going to be covering. So you start to have problems in the traditional broadcast workflow when you're trying to do that for a bunch of reasons when we get to the transmission side, which I'll now blow up. So this is a rough idea of what a traditional sports workflow could be. Obviously they're all different, but this is just trying to generalize it and make it as simple as possible. And one of the biggest issues we have here is generation loss in terms of encoding and then encoding again. So it's photocopying a photocopy. And in this workflow, you have usually a first generation just getting your content to ingest. It depends how you're doing it. Obviously, if it's a satellite, it could be different. Depends where your final assembly point is, whether you're handing that off to a vendor or whatever. But you usually have one generation there. You're going to have a second generation when you transcode it, when you create your renditions and your ladder to put on your own platform, or you're going to hand it off to a partner who's going to do that for you, and then you maybe have to send it over to them if they're in a different location. You also might have another generation lost on the actual platform itself. If you're hosting your own platform, you're in total control, but that's not always the case. If you're handing over to a public platform, they're going to transcode it again. So you can have a bunch of different generations lost. If you're doing a remote production, it can even get worse, but we won't talk too much about that. When we talk about the esports workflow, it's a little bit different. First of all, the diagram is simpler. And in general, we tend to just have one generation of loss. And this is because our focus is completely different to traditional sports. Traditional sports, a lot of it is behind paywalls, it's subscription services, they're building their own OTT. All of our content is going out to public platforms. So we're focusing on those platforms because that's where our viewers are. All of our viewers are watching for free on a public platform, so that's our focus. We want to try and get the highest possible quality to those viewers, and the best way to do that is to get them a first generation when possible. So for example, Twitch, they'll allow a first generation pass-through. They also transcode it, but they'll allow a first generation pass-through, so we want to take advantage of it. So our entire workflow is designed to do that. We will encode on site, we'll ingest, we might repackage it, we might move it around or reroute it or delay it or something like that, but we're not going to re-encode it, and we pass that straight through essentially to the viewer so we can get the highest possible quality. And that's basically what I just said. The problem, well, it's not a problem, but the meaning of that is if you're going to do a first generation workflow from on-site encoding all the way to the viewer, then you have to essentially, your first encode on-site has to be platform compatible at the end. So you have to do a very high quality encode, a very low bit rate. That tends to need a lot of power. So how are we going to do that? We do that with our own encoding equipment. Essentially, everything has to be done on site for that first generation. We're not going to buy off-the-shelf traditional hardware encoders because they basically don't focus on this use case. You know, they're usually for backcalling content or for a number of different purposes, but they're usually not doing a really high quality encode with a really low bit rate. That's not what they're designed to do. And they're prohibitively expensive at scale, which is another problem. So we're going to use our own hardware. We're going to buy consumer level hardware, build our own servers. We're going to run open source software on them. So for very little investment, we can have a huge amount of power. We can have unlimited GPU, unlimited CPU to do whatever we want on site. So that's how we can do that first generation encode that goes all the way to the end. What that also allows is for us to do multiple renditions on site, because obviously we still have to create different kinds of stream. You know, there might be a different taker who wants something completely different. If you're going to send a feed to Amazon Prime, to DAZN, to Facebook, you know, they'll want different specific settings. So we will try to cater our streams for that and do it on site. The good thing about using your own hardware, your own software, is you have the ability to scale quite cheaply. The reason you wouldn't want to do that in the past is because you would not want to do all your encoding on site and then have the strain of taking that out over the internet. That's not really the case anymore, and especially because these streams are all platform compatible, their bitrate is very low. So for one of our major events, we'll do all of our renditions, all our different streams for all platforms, tons of backup, linear TV stuff, everything probably in about 250 Mbit over multiple ISPs. That's barely enough bandwidth to take two 1080p signals back with J2K, and then you have to do it over a managed network. So approaching this way, you have a bunch of advantages where you have much higher quality end-to-end, first generation encode. You have less investment in your hardware. You don't have to transcode, so you have higher quality. You don't have to pay for transcoding. It's everything is basically tick box, tick box, tick box. So essentially, because of the demands of in-game being much higher than cameras, it forces us to look for other options, and then what that actually leads us to is financial savings and just higher quality in general, simpler workflow in general. So I quite like this example. The next one, what about latency? I hear nobody ask, but I'm going to ask what about latency. This one comes up all the time, right? In TV and broadcast, everyone's talking about latency. And what they're talking about, this is a traditional broadcast workflow just all put together, and essentially they're talking about the time it takes from something happening live to the OTT viewer seeing it. And usually, it's in a workflow like this. You have latency between live and ingest. You have the latency between ingest and the TV handoff. And then you have latency between TV and OTT. In traditional sport, they're prioritizing the linear TV handoff. That's what is the most important thing. And OTT is like kind of an afterthought. It's get the content back as fast as possible, get it on TV, and then get it to OTT. So you get the story that you always hear, everybody talks about it over and over again, is a goal is scored, everyone cheers, a few seconds later, everyone on TV cheers, and then OTT waits to see what happened. And everybody's trying to solve this problem, but they only try to solve it here in this area. Every discussion is about how can we make the time between the TV viewers and the OTT viewers shorter. How can we close that gap? And people are trying to invent new protocols and new workflows and new technology to try and do that. In esports, we take a different approach. We basically just avoid it. We do our latency between live and ingest, and then we have latency between live and OTT. And we serve our linear TV handoff from the same infrastructure that we do our OTT delivery. So you might say, well, you're not really solving the problem, you're just moving it. But what we find is the real problem is not the time between the people in the stadium and the OTT viewers. The real problem is the time between TV and OTT. So rather than trying to shorten that gap, just hold television back to the point that OTT is at, and then the problem goes away. This is assuming that you have a short enough round trip. So our diagram would look something like this. We just get rid of that time. Obviously, if it's 30 seconds, if it's a minute, that's way too long. That's an eternity in sport. But what we see is with public platforms like Twitch, like YouTube, like our end-to-end time is 10 seconds or less. And 10 seconds is pretty acceptable when you think about the time from, that's 10 seconds from when it hits the encoder at the venue to the OTT viewer watching it. In sport, that's pretty acceptable. That's very little time for any spoilers, anything like that, and we obviously have millions of watch hours with viewers. You know, we're not seeing any complaints about this workflow, we're not hearing any problems with this, so we think this is acceptable, and it's achievable, you know, with no special build-up, right? Essentially, we're doing this with public platforms. So this is a pretty good example of how esports looks at something differently because we have a different objective, right? We're trying to serve a different user in a different way, and that leads us down a path where we actually discover something that it feels like everybody else is missing. Obviously, it's not going to work for everybody. If you're constrained to a platform, you're building it yourself, you have technological limitations or things that are being put in place, it's hard to change. You can't just do this and reap the rewards. But it's more from the perspective that it's possible. You don't have to spend all your time figuring out how can we shorten this distance. You might just be able to change your workflow and it won't matter. Like, ultimately, you're not competing with the people watching in the stadium, you're just competing viewer against viewer, and you can make that essentially go away. So there's some bullet points just covering all that stuff I just said. Essentially, we're focusing on the viewers end-to-end, we're prioritizing OTT, we're synchronizing based on the glass-to-glass time, but for an OTT viewer, not for a TV viewer. We're affecting the latency purposefully when we need to, so we're holding television back. If television's going to be 9 seconds ahead of our Twitch viewer, then we're going to hold them back to that level, so no viewers are out of sync. And the bonus is you reduce generation loss, you do less transcoding, it's a win-win. So what comes next? I didn't expect to have this much time left, so that's good. Essentially, the current landscape in esports, I just wanted to go through those 2 examples because I think those are 2 obvious and good ones where traditional sports and esports face similar challenges, but we approach them completely differently for different use cases. Where esports is right now is everything is at a super high level, I think. Our broadcasts are equal or in some ways higher than a lot of sports broadcasts. The reliability is super high. The quality is excellent, I think superior to a lot of traditional sports you're going to see. The bar is set very, very high. The business model is the interesting bit, where in esports there's no paywalls, there's no subscriptions, everything is free. So it's all about partnerships, sponsorship, ads. It's trying to build up a model that makes sense there, where essentially everything we're doing is on the same level as traditional sports, but everything for them is paywall, subscription, massive media rights sales, and in esports it isn't like that. So that's the tricky part about where esports is right now. Everything is on the traditional sports level, but the business model is nothing like traditional sports. It couldn't be more different. Where we are going in the future, based on that, the technical considerations, it's about trying to follow more workflows like those examples I talked about. We want everything to work over the public internet. We want to design workflows that work for all levels. We don't want proprietary technology, managed services, anything like that that's going to hinder or restrict what we can do. We want to basically make workflows that are going to work for the biggest of the big, but also the smallest events. I think I say this all the time. I was saying this constantly at NAB. It's easy to do more with more, right? It's easy to do the Super Bowl with a Super Bowl budget, but quite often you have to do a Super Bowl and you don't have those resources. And I think there's 2 problems with that. One is just not being able to execute. The other is you set kind of artificial quality bars where you basically say this is how good the Super Bowl is, but then we do this event and it can't be as good. Like, why? Because we don't have the resources. So it's better, in my opinion, to try and figure out a workflow that caters to everything, and then what you do is you save costs at the top level, but then it also lifts everything at the bottom level up in quality, but also you don't have to have multiple workflows, multiple sets of infrastructure. This show can have that, but this show can't. It just simplifies everything. And then using those technology to drive the features, and that's where we talk about the business model. Everything we want to do is about serving the gaming community, the esports community. It's only features that they want, only things that they are interested in. Because essentially we're trying to find this sweet spot where esports is viable as a business, but without these insane media rights deals that traditional sports has now. We're probably going to hear more about that later, about how that's becoming problematic. We are focusing on the user experience, and most of our viewers are watching on OTT, on public platforms, right? So we're focusing on them. What do they want? They're going to get the content for free. That's not really going to change. I don't think that's on the table. The question is, what more can we give them? What can we do Where should we be investing our money to upgrade that experience? And then there's possible avenues for monetization there. The most important thing for me as someone who's working in a technical area, we don't want to waste any time on gimmicks or tech demos or anything like that. Everything has to be purposefully serving the viewers. Like, what do they want? What are they interested in? Like 4K is a really easy example there, where people talk about when is esports going to be in 4K? It should be in 4K. It's computer games. Everyone plays them in 4K. The answer to that is it's the frame rate problem. Essentially, nobody is interested in the resolution. They're interested in the frame rate. So if you're going to do 4K, you have to do 4K 60, and then the real problem is the production workflow. Like, streaming is kind of the easier part when you're talking about that. It's the production line changes that are more expensive, hugely impactful. Taking something from 3G to 12G is a big deal. So this is our thinking in the future, where we're going, with our tech plan, in terms of we want to keep upping the experience, upping the quality, gaining efficiency, obviously, saving money. But the idea is driving towards something that isn't, the purpose isn't to stand on a stage like this and talk about how amazing our new infrastructure is or our new toy is. Like, the purpose is to give esports fans more to watch, more to be excited about, more features, whatever they want, serving their needs, and then essentially growing esports. So that's pretty much everything I had prepared to say. But in conclusion, why I think it's worth listening to this talk, why I think it's worth looking at esports. I think for a lot of people in this room, maybe you are involved in esports, maybe you're interested in esports, even if you're not. I think esports is really something to pay attention to, just because of all this stuff that I just ran through. We have specific challenges in esports that are unique. You don't find them in traditional sports, but also the technical bar is incredibly high. You know, the standards are very high. It's a very, very similar world to traditional sports, but it's completely different. And I think if you're designing a product, or you're building a service, or you're making a tool, or whatever it is that you're doing, essentially, if you make something that is good enough for esports, then it's going to be good enough for all sports. And that's, I think, the key takeaway that hopefully I could achieve today. So thank you for listening, and let's go get some coffee.